let's begin today's lecture. Last lecture on Sunday, if you remember, we talked about an important random variable, the Gaussian random variable, and we introduced the PDF and the CDF for that random variable. And also we introduced two functions, the phi function and the Q function, where we use them to describe the CDF for the Gaussian random variable by using the parameters for the random variable. And we had a few examples illustrated to help us understand how to deal with these Q function and phi function. And today we're going to continue. We're going to introduce briefly some other important random variables. Obviously, they are continuous, as the case with the Gaussian random variable. We're not going to go through these random variables in details. We're just gonna introduce to them so you will know about it. Okay. The first one on the notes here, as you can see on the screen, it's uniform random variable. The uniform random variable, we've seen that before. If you remember, a couple lectures ago, or maybe chapter 1, maybe. Or no, maybe chapter 2. We introduced the CDF and PDF, and we were given, as an example, we had a PDF was given to us, which is an equation 1, and we did derive the CDF from the PDF by taking the integration of the PDF, the fx, from -infinity to x, and you can go back to that example if you want. And as you can see, we had, of course, figure 1, figure 2. These are graphs for the PDF and the CDF. So that's all we need to cover as far as these random variables. We're not going to go through a lot of details like we did in the case of Gaussian. The next one, it's widely available and has a lot of applications. Exponential random variable. Okay, we all know how to deal with the exponential functions. Okay, exponential random variable. It's given in equation 3. The PDF for it is given in equation 3. Okay, and also the fx for it is in equation 4. Of course, again, if you have the CDF, if you have the PDF, you can get the CDF and vice versa. Okay. And these are figure 3 and figure 4. These are just the description or graphical representation for these PDFs and CDFs for the exponential random variable. In some cases, A, the parameter A, it will be shifted to 0, back to 0. And in this case, the PDF for the exponential random variable would be given in equation 5, and the CDF would be given in equation 6. In terms of unit step function would be, because in this case b larger than 0 and a is equal to 1. So it will be, we have nothing in the negative. Okay. So you might see it in some books in this form as in equation 5 and 6, which means a is equal to 0. It's shifted back to 0 from to the left. Okay. So these are two random variables. The third one on page 43. It's called Rayleigh random variable. Okay. Now, Rayleigh random variable, it's an important random variable, or it's an important distribution, mathematical distribution for communication. They use it heavily. It's used heavily in wireless communication, which represents the distribution or the channel between the let's say the tower and the user. Okay, and in this case, you would have it's called non line of sight. Non line of sight. It means you can't really see the tower. Okay, so you would have a lot of obstacles between you and the tower. Okay, so it means there's a lot of fading between this fading channels heavily faded. Okay, and in this case, it's described by Rayleigh random variable. Of course, if you if you're gonna, if you're gonna take, let's say, mobile or wireless communication in the future, 559, Rayleigh and also Ryson here, it will be discussed. Ryson right here, okay? It's yet another wireless communication channel, okay? Rayleigh, it will be discussed in more details and how to apply it and how to use it to find خلينا نحكي bit error rates and things like that. But anyway, for this course, we're not really interested in that. We're not going to go through a lot of details. All we are doing here, we are just introducing the random variable for Rayleigh, which is in equation 7, and also the CDF in equation 8. And also figure 5 and 6. These are just graphical representations for the PDF and the CDF. In addition to the 3 random variables we just mentioned, we have additional ones that are in your book, in the textbook, in Appendix F, like, for example, Laplace random variable, gamma, Erlang random variable. Again, like Erlang, it's also used in communication. Also, we have chi-square random variable and Ryson random variable. Okay. So these are just, so you would know. I mean, this is, we're not gonna have any details analysis on this or in questions or anything like that. Okay, this is just for your information. So if you've seen that in books in the future, you will know what they mean, or whether they are random variable, whether continuous, or whatever, something like that. Okay. The last topic we're going to discuss in chapter 2, it's the conditional distribution and density function on page 44 of the notes that you have on the screen. As far as the conditional probability, we discussed that back in chapter 1, if you will. Just to refresh your memory, the definition of the conditional random variable is given in equation 9, as shown on the screen right here. And basically, the probability of the event A given event B, it's equal the probability of the intersection between A and B divided by the probability of B. Okay, so we've seen that before. Now, we can use this equation to find the conditional distribution and the density functions, which means that if we assume that event A is identified as the event x less or equal x less or equal to small x for random variable x, okay, then we can use equation 9 to find the conditional distribution, okay, of x. So the distribution, the fx or the CDF, it's fx. Now, all we're doing, we're adding slash b. It's a condition, okay? So fx condition on b, okay? So the conditional distribution function, it will be given in equation 10, which is the probability of the event B, A, intersection of event A and B divided by the probability of B. Okay. And since we are talking about distribution, or we're talking about CDFs here, fx, of course, the properties of, if you recall, when we discussed the CDF and PDF at the beginning of chapter 2, this chapter, we had some properties for the CDF or the FX. And these properties are listed here. Basically, they are the same properties. They are 6. Okay, we discussed 6 of them. And the only difference is we have a slash B. So it's a conditional property. So, for example, the first one, at the beginning of chapter 2, we said fx minus, the fx of minus infinity is equal 0. In this case here, the conditional distribution, we say the fx of minus infinity given event B happening is equal to 0. Okay, it's the same thing. Okay, so I'm not going to go through it again because we did that before. These properties apply to the the conditional distribution the same way it was applied to the CDF itself. Okay. And the next page, we'll continue talking about conditional density function now. Now, if we have the fx, if you remember the beginning of chapter 2, sorry, if we have the fx, okay, we can find the PDF for it. If we have the CDF, we can find the PDF by taking the derivative of this CDF. And the same thing here. So we do have the conditional CDF of x, okay, the conditional distribution of x. So all we have to do is just take the first derivative of that conditional CDF with respect to x, and that will give us the conditional PDF, okay? Nothing changed. Like I said, you know, all the information we are talking about here in chapter 2, they will continue with you. I mean, like we go to chapter 3, chapter 4, 5, and all that. We're always going to go back to chapter 2 and these chapters right here. So they are connected to each other. And of course, we're not going to go and explain them again because, you know, we went through and we had examples and whatever. So you should be able to review it yourself. Again, the properties of the conditional densities are the same properties for the PDF, the ones we discussed at the beginning of chapter 10, okay? Chapter 2. Keep repeating 10 and 9, okay? All right. So lastly, we're going to talk about just an example, small example, about the conditional property. Example on page 46. It says here, x is a random variable, okay? Let's assume that event B is equal, the random variable x is smaller or equal to B, where B is some real number between -infinity to infinity, okay? And the question is, we need to find the probability distribution function of x conditioned on the event x less than B. So basically, what we're saying is we're going to go back to this page right here, okay? So we have f of x conditioned on B. B in this case is, of course, it's the same as equation 10. The only difference is B is given to us. B is the random variable x is less than B, small b, okay? And this one is x less than or equal to small x. So we do apply equation 10 as shown here. And it's going to be the probability of the intersection between event A, which is in this case event A is x less than small x, and event B, x less or equal to small b, divided by event B, okay? Where it's not shown here, event B, the probability of event B is not equal to 0, of course, because this one is not. If it's equal to 0, it's going to go to infinity, okay? All right. Now we're going to consider two cases. The first case where small x is larger or equal to b. And the other case is when x is less than b. Now, if b is less than x, as shown here, if b is less than x, it means that event A, it means event B, okay, is a subset of event A, okay? Because B is smaller than X. So if we want to take the intersection between B and A and X, okay, it means between the two events, the outcome would be event B, because event B is the smallest, right? So this is the outcome, okay? So you take this outcome, the probability of the intersection between this event and this event, A and B, it's really the probability of event B, which is x less or equal to B. Now, when you divide them, when you apply, go to equation 12 and plug in the numbers, plug in the outcome, it's going to be equal to B. This is the case where B less or equal to A. b is less or equal to small x. All right. Now, in the case of x is smaller than b, it's the opposite. Okay. In this case, event A, which is x is less or equal to x, small x, is a subset of the event B, right? Which means the outcome of the intersection will be event A. So if we go back to equation 12 and plug in the outcome, you will see the fx of x given event B is equal to the probability of x less or equal to small x divided by the probability of x less or equal to b. Now the first one, the probability of x less or equal to x, it's really the CDF of x, the CDF of x, random variable x. And the other one is the CDF of b, okay? So if we combine equation 13 and equation 14, this is really the conditional CDF, okay? Now, what's required? We need to find the probability distribution. We need to find the PDF. Now, we did find the CDF. The CDF was 13 and 14. And to find the PDF, we need to take the integration, the first derivative of the first one and the second one. Of course, the first derivative of the first one is 0. The first derivative of 1 is 0. Okay. Now, and then if we take the derivative of equation 14, as you can see here, the first derivative of the CDF is PDF. So the first derivative of the fx of x is equal the PDF as shown in equation 15 here. And the numerator, we have the CDF of b. B is a constant. So there's, then the derivative of the constant would stay as is, okay? So when we combine the outcomes, okay, it will be shown in equation 16. So when x is less than b, it's, as you can see, it's the PDF of x divided the CDF of b. And when x larger or equal to b is equal 0. And this is basically the end of this example. Any questions? Okay. And this is also the end of chapter 2. And normally I like to give some suggested problems for the end of each chapter if I can. So in this case, I have selected a few suggested problems here. Try to do it yourself, and if you feel like, of course, I suggest you do all the examples in the book and try to understand the examples we discussed here, and I think you will be in a good shape. Okay. Any questions on these notes today?
لا دكتور كله تمام.
Okay. If you didn't have any questions, then like I said, inshallah, next Sunday we'll begin with chapter 3, and have a nice day. We'll see you. We'll talk to you inshallah next Sunday. Assalamu alaikum wa rahmatullah.
يعطيك العافية.
Allah